This video is to review the different types of factoring. So the first type of factoring we're going to look at is greatest common factor, which is also called GCF. The greatest common factor divides into two or more terms. So a couple examples here, just to show you that you can have a GCF of a number, a variable, or a number and a variable. Always look for the number that is the GCF first, then go down the line for your variables. Remember, not every variable will be a part of your GCF. When you're figuring out which variable is a part of the GCF, it is the one with the lowest exponent that every term has. So if every term doesn't have a variable, then a variable is not included in the GCF. So if we see here, there's no variable with the 4, so it's not included in our GCF. So let's look at some examples. Factor by GCF. Number 1, we have 4x plus 6. So I have to look at 4 and 6. What's the greatest common factor of 4 and 6? It's 2. So remember, your GCF goes outside the parentheses. So my GCF is just 2. When I pull out a GCF of just a number, I'm going to divide my terms by that number. So 4x divided by 2 gets me 2x. 6 divided by 2 gets me 3. Number 2, 4g cubed minus 7g squared. So my GCF here, there's no common number between 4 and 7. But they both have a g, so I need to look at the lowest exponent, which is a 2. So we can take out a g squared for my GCF. When I take out a variable, I have to subtract my exponents. So 4 stays, 3 minus 2 is 1, so it's g to the first. We don't have to write that. Minus 7, 2 minus 2 is 0, so there's no more variable with the 7. Number 3, my GCF between 8 and 16 is 8, and they both have a y. My lowest coefficient here is exponent here is a 1, so I'm going to pull out a y. So I have 8y. So when I divide, 8 divided by 8 is 1. 2 minus 1 gets me just y. Here they both have a y, so they are eliminated. 16 divided by 8 minus 2. 4, 5, and 6 are the same ideas with a couple more variables. So here my GCF, 11 and 19 don't have anything in common. With the g, my lowest exponent's a 4. With the h, my lowest exponent's a 2. So my GCF is g to the 4th, h squared. And in parentheses, I leave the 11. 5 minus 4 gets me a g. 2 minus 2 is 0, so there's no more h. Plus 19. 4 minus 4 is 0 for the g. 4 minus 2 gets me h squared. In number 5, the greatest common factor between 12, 15, and 9 is 3. And then I look at my j's. My lowest j exponent's a 2. So j squared. So I'm going to divide my numbers. 12 divided by 3 is 4. Subtract my exponents, j to the second. Negative 15 divided by 3 is negative 5. 3 minus 2 gets me j. 9 divided by 3 is 3. And there's the exponents subtract to 0. In number 6, I have 22, 33, and 55, so my greatest common factor is 11. Now, w is not part of the GCF because this term does not have a w. They do all have z's, though, and the lowest z exponent is 3. So I'm left then with 2w to the squared, z to the 4th, minus 3, because 33 divided by 11 is 3, wz squared plus 5. My second time of factoring is to factor a polynomial. So I'm going to use a box problem. In a box problem, when we draw our box, we're always going to have our C value on top and our B value on the bottom. Remember that we are multiplying to the C value and we add to the b value. So in number 7, I'm looking for two numbers that multiply to 21 and add to 10. So when I think about factors that multiply 21, I can think of 1 and 21 and 3 and 10. 3 and 7. Sorry, 3 and 7. So which of them add up to 10? Well, it's 3 and 7. So I would have x plus 3 and x plus 7. Your variable gets written with each factor. Okay, also remember when we use a box problem that we have to have a leading coefficient of 1 in front of the x squared. It has to be a positive 1. Number 8. What multiplies to 5 and adds to 6? Well, those numbers are 1 and 5. So we'd have x plus 5 and x plus 1. Number 9. We need numbers that multiply to 30 and add to negative 11. Now, because we're adding to a negative number here, we have to think of numbers that are both negative so that they multiply to a positive but add to a negative. So in this case, those numbers would be negative 5 and negative 6. So we'd have x minus 5 and x minus 6. Number 10, numbers that multiply to 12 and add to negative 7. So again, we need two negatives, which are negative 3 and negative 4. So we have x minus 3 times x minus 4. Let's look at a couple more examples. So let's look at a problem where I have x squared minus 2x minus 15. In this case, we need numbers that multiply to negative 15 and add to negative 2. So in this case, we need a negative and a positive. So what numbers multiply to 15? Well, the most common is 3 and 5. 5 has to be the negative because we're adding to a negative 2. So I'd have x minus 5 and x plus 3. Let's look at one more example similar to this. So it's x squared plus 4x minus 21. So in this case, we need numbers that multiply to negative 21 and add to positive 4. So because 21 is negative, we need a negative and a positive number. So numbers that multiply to 21, first one that comes to mind is 3 and 7. Because the 4 is positive, the 7 stays positive. So I have x plus 7 and x minus 3. Now let's put these two ideas together where we have to factor out a GCF before we can factor the polynomial. We can't do a box problem yet because these do not have leading coefficients of an x squared term with 1. So in number 11, the number that is my GCF is going to be 3. So I'm going to take out a 3 and I'm left with x squared plus 5x minus 24. So now I can do a box problem. What multiplies to negative 24 and adds to 5? So I'm thinking of a negative and a positive number. So I have negative 3 and positive 8. So this 3 for the GCF still stays out front. And then I have x minus 3, x plus 8. In number 12, I don't have a leading x squared term. So I need to look for a GCF. The GCF here is x, which decreases all of my exponents by 1. So now I need to know numbers that multiply to negative 36 and add to 9. So those numbers would be 12 and negative 3. So the x stays because it's a GCF, and then x plus 12, x minus 3. Number 13. In number 13, my GCF has a number in front of it, and it doesn't have an x squared term. So my GCF here is 9x, so I'm going to divide everything by 9 and decrease my exponents. So I'm left with x squared plus 14x plus 24. So now I need to look at numbers that multiply to 24 and add to 14. So those numbers are 12 and 2. So my GCF stays 9x, x plus 12, x plus 2. The last thing we're going to look at is zero product property. So with zero product property, when your set equal to 0, you're still going to factor. So in 14, this has two terms, so it has to be a GCF problem. So my GCF here is x. So I'm left with x minus 4 equals 0. Now, because it's set equals 0, we're going to use the zero product property, where we take each set of parentheses or term and set equals 0. So we have x equals 0 and x minus 4 equals 0. We're going to solve for x. This one, x is already solved for. Here I'm going to add 4, so x equals 4. So I'm going to get my solutions at the end using zero product property. 15. I need numbers that multiply to negative 14 and add to negative 5. So those numbers are negative 7 and 2. So I have x minus 7, x plus 2 equals 0. And I'm going to use the zero product property. So I'm going to set each of these equal to 0. X minus 7 equals 0. Add 7, so x is 7. Or x plus 2 equals 0. Subtract 2. X is negative 2. (16) I have to look for a GCF. So the thing that everything has in common is a 2x, which leaves me with x squared when I decrease my exponents and divide, minus 3x minus 4 equals 0. So I need to find numbers that multiply negative 4 and add to negative 3. So I need a negative and a positive number. So I'm going to have negative 4 and positive 1. So I have 2x times x minus 4 times x plus 1 equals 0. Use the zero product property, so each of these gets set equal to 0. And I solve for x. So I would divide by 2, x equals 0. Add 4, so x is 4. Subtract 1, so x is negative 1. Number 17, I have to look at my GCF, which in this case is 5. Everything else stays the same. X squared plus 6x plus 8 equals 0 when I divide by 5. I need numbers that multiply to 8 and add to 6, which are 4 and 2. So we have 5 times x plus 4 times x plus 2 equals 0. Now, when I use zero product property, this 5 doesn't have a variable with it, so I don't need to set it equals 0. I just have to look at my parentheses. X plus 4 equals 0, x plus 2 equals 0. So x equals negative 2, x equals negative 4.